So today we are talking about transformation of functions. So for this, I highly suggest you only write down what I highlight and then write the graphs. Anything else that I might add, but there is a lot of writing for this one. So we have to talk about reflections, translations, and dilations. Reflections is the first one. And reflections is when we reflect over the X or Y axis. So again, anything I highlight, I highly suggest you keep in your notes. Down here, I know that a graph like this is x squared. So for all intents and purposes, I'm going to call this x squared. It is a little bit different, but that's okay. It's close enough. And this one would be negative x squared. So when I'm flipping up and down, the negative goes all the way outside. So this is technically x squared and then negative, if we wanted to get really specific. The next one is over the y-axis. And again, I'm going to call this blue one x squared. And now for this one, this is negative x squared. So the big difference between the two, one, the entire function is negative, and the only x is negative. When we come down to translations, this is when I either move my graph up, down, or I move it left and right. Right here, this says that if it is a positive number, we go up, and if it is a minus number, we go down. So an example would be x squared plus 2 and x squared minus 2. Over here at our graph, again, we're going to call the blue one x squared, which means this green one is x squared minus 2, and this red one is going to be x squared plus 3. Notice the plus 3 and the minus 2 do not affect the x. They are tagged on at the end. Now when we come down to moving left and right, this right here is really important. A positive, so if I have x plus 2 squared, that means I move to the left. And minus 2 is to the right. Again, we're going to call that x squared. This one would be x minus 2 squared and x plus 2 squared. We also need to talk about dilations, which happen vertically and horizontally. So first we're going to talk about vertical. And there's a lot of information here. I highly suggest you write down these first several lines, which means you may or may not want to pause to make sure you get it all copied in your notebook. So, vertical stretching is going away from the x-axis, and compression is towards the x-axis. So if we have a number that is greater than 1, so basically whole numbers, that means it is stretching, and that means it is going away from x. For the second one, a fraction or a decimal, and fractions and decimals go towards x. So notice my green one, that is 2x squared. My red one is 0.5 x squared. Now, notice my green one, it's a whole number. Whole numbers mean we need to go farther away from x. So you'll see from blue to green, it did move farther. And then the opposite from blue to red got closer to x. So again, I suggest you probably pause this to make sure you get everything written down that you can. And then we're going to move on to horizontal, left and right. Now, on the last time we talked about left and right, I told you that left and right is a little weird. The same method follows through for this one. It's going to be the exact opposite of what you want it to be. Again, I know this is a lot to write down, so I do suggest you probably pause to make sure you get it all written down. Now again, this one is kind of the opposite. So stretching is away from y, compression is towards y. So if we have a whole number, it is shrinking. And I know shrinking means towards y. And horizontal is stretching. So my fractions and my decimals go away from y. So if I look here, this one would be 2x squared. And when I look, my graph, it was here, and now it's here. It moved in. And then also for this red one, that's 1/2 x squared. Again, my red one moved farther out, just like I said it would. Now we're going to briefly just talk about this chart. If you do not have the paper copy, I do highly suggest, again, you pause and write down in your notebook. I'm going to give you the examples. So we're going to use x squared as our base function. So if I wanted to move it up, I would say x squared, let's say we move it up 2, and move it down 2 would be -2. To move to the left, we +2 on the inside, and to the right, we -2 on the inside. Again, remember these two are a little funny. Left and right is always weird. Reflect over x, I would have negative x squared, and reflect over y, I would have negative x squared. So notice the difference in our negatives. For a compression, or I'm sorry, a vertical stretch, we're going to use 2 again. I would do 2 times x squared. And for a compression, I would do 1/2 times x squared. And for horizontal compress, would be 2x squared, and a horizontal stretch would be 1/2 x squared. So there's some like visual examples of something. So hopefully that one makes a little bit more sense to you. And now all you need to do is go through and complete the activity for class.